This is part 2 of sum, difference and product functions, and this is for learning intention 38. So in part 1 we did addition of ordinates, which is we have two graphs and you add the y values together to get another graph. So in this part we're going to look at taking the difference of two graphs to sketch another one, and also the product, so multiplying two functions together to get another function and how we sketch that. I've got two examples here, but the first thing I want to do is to clear up what this is about by doing an example of addition of ordinates. So I want to go back to part 1 and I want to give you this example. So this is going to be, we're going to work out what 3 plus 4 is, but we're going to do it using addition of ordinates, which sounds ridiculous. It is. We know that the answer is 7. But by doing it with addition of ordinates, hopefully you'll see what the method's actually about. So let's define some function g of x to equal 3. Let's define another function called h of x, which equals 4. And let's call f of x the sum of g of x and h of x. Alright, so we've got g of x equals 3, h of x equals 4, and we've got f of x, which is the sum of these. And suppose the question said, use addition of ordinates to sketch f of x. Alright, what would this look like? Well, we're going to draw up a set of axes, and with addition of ordinates, what we do is we sketch each individual graph. So let's do that. So we've got two parts to it. We've got g of x and h of x. So we're going to draw a nice big set of axes. And let's do g of x first, which is 3. So y equals 3 is a horizontal line that goes through the y-axis there. So we have 0, 3 like that. And let's sketch another graph, which is h of x, which is the graph of y equals 4, which is a horizontal line which goes through the y-axis at 4, so that's 0, 4. Now it's saying use addition of ordinates to sketch f of x. Well, we've got g of x and h of x. Now we have to add each of the y values together to figure out how to get f of x. Well, let's see, that y value is 3, that y value is 4. So if we add them together, we're going to be at 7. So 7 might be there. That y value is 3, that y value is 4. So adding them together, we're going to get 7, which is there. That y value is 3, that y value is 4. They're going to add and hit 7. Same over here. And you'll notice something. Oh, that forms a straight line. That's a horizontal line there. So that line is f of x, and that's 0, 7. And we've just done addition of ordinates to sketch f of x. Now, your grade 1 maths tells you that you didn't need to do that because you could have worked it out like this. However, for more complex examples, which we'll be doing here, you can see why this technique will be necessary. So for things like constants or really simple graphs, you don't really need to use this technique. But when it gets to trickier graphs, you need to think about addition of ordinates. Okay, so let's have a look at this example here. So we'll call this example 2. So it wants us to sketch g of x minus h of x. So we've got g of x and we've got h of x, and it wants us to sketch their difference. So now we're moving on to sketching a difference of two functions. So this time we're doing the difference of two functions. How do we do this? Alright, let's write this out. Well, let's define the difference as f of x, and that's going to equal g of x minus h of x. Okay, so we have our g of x, which is, and I'm going to use different colors here, our g of x is negative the square root of x plus 1, and we have minus our h of x, which is x. Alright, so we've got negative root x plus 1 as g of x, and we've got minus x for h of x. So we know how to do addition of ordinates, we know how to add the y values. How do we subtract the y values? Well, the best way to do it, I think, is just to make it an addition of ordinates problem. Just turn it back into a sum. So another way to rewrite this, to turn it back into a sum, is to write out the g of x, that's fine, keep that as x plus 1. Change the minus to a plus, so now we're doing addition of ordinates, but instead have minus x. Now adding a negative gives a negative there, so that's fine, but now we're doing addition of ordinates. So you can see that these two are the same thing, we've just rewritten it. The difference is this graph here is reflected in the x-axis. It's got a minus out the front, it's reflected in the x-axis. So let's sketch this graph. Let's see how to do this. How do we tackle this problem? Alright, we start with nice big axes, and we're going to sketch each part, and then we're going to add the ordinates. So I've got x and y. Alright, this negative root x plus 1. Let's do DRT. So dilations, no dilations. Reflections, yep, we've got a reflection in the x-axis because the negative's out the front. Translation of 1 unit to the left. So it's going to start out like this. It's going to be reflected in the x-axis. I've gone off the screen there, and it's going to be translated 1 unit to the left. So it'll look something like that. This graph here, if we do a quick DRT, no dilations, so it's just the graph of y equals x, straight line. There we are. But it has a reflection in the x-axis, so it's going to look like that, and there's no translations, so it's going to look like that. Alright, let's sketch both of these graphs on the set of axes. So we've got the square root graph going down like that, and we have our negative x graph, which is going to look something like that. Okay, let's put in these coordinates. So this coordinate here is going to be negative 1, 0. This y-intercept for the blue graph is going to be 0, negative 1, if you sub it in and work that out. And then we're pretty good. We don't really need the intersect, of the two graphs, because we're concerned with f of x. That's the one we want to sketch. And we know that that point's 0, 0. Okay, how do we sketch f of x? Well, there are some important points to look out for which are going to help you. So, to start off with, anything to the left here is undefined because you can't square root a negative number. So anything less than negative 1 is undefined. Even though this here is defined, the green line, if you have defined plus undefined, it's undefined. It doesn't exist. So anything to the left here doesn't make any sense. So we're going to have to start here. Now, where's our starting point? Well, this y value is 0. So we've got 0 plus whatever that is going to be whatever that is. So that's our starting point there. That's where f of x starts, because it's 0 plus whatever that is. Okay, what is that? Well, it's f of negative 1. So let's work that out. F of negative 1 is negative root negative 1 plus 1. And that's going to work out to be plus 1. So that's positive 1. So that's going to be the point negative 1, 1. That makes sense. Okay, what other important points can we look out for? Well, here, this graph equals 0, and we're going 0 plus negative 1. 0 plus negative 1 is negative 1. So this is also a point on f of x. Right here, see, because on the green curve it's 0, and we're adding negative 1, that y value, so that's going to be a point as well. What do we do now? Well, we've got to figure out what goes on here. So you can see it has to be a curve that joins these two dots, so it's going to be a curve that passes through here. And over here we've got a negative plus a negative. See how all these y values are negative? If you've got a negative plus a negative, you're just going to get more negative. So over here it's just going to be negative. So you can see that your curve's going to pass through here, and it's going to be negative over here. So that suggests an x-intercept. Let's try to find the x-intercept. That's good practice. Let's see if we can without a cas. So x-int will make y equals 0. Okay, let's do it over here. We've got 0 equals negative root x plus 1 minus x. Alright, that is going to be quite the challenge. Let's see, so x equals negative root x plus 1. Let's square both sides. We get x squared equals x plus 1. Then you get x squared minus x minus 1 equals 0. What are you going to do there? Yeah, it's not going to be pretty. You'd have to use the quadratic formula. So you get minus b, so 1 plus minus root b squared, which is 1 plus, well, minus 4ac, which is 4 on 2. So you're going to get 1 plus minus root 5 on 2, which is actually the golden ratio. So 1 minus root 5 on 2. Yeah, it's not going to be a pretty value. It's going to be 1 minus root 5 over 2. And I'm pretty sure if we looked at the answers, it wouldn't have that point in there. It's not being very clear, but that's okay. That's what the point would be, but let's sketch that. So it's going to pass through the x-axis. I'll try that again. It's going to pass through the x-axis and go like that. Okay, that should be smoother. I'm going to be very stubborn. I'm going to try that once more. Nice and smooth. Smooth curve. Okay, there we are. That's our f of x. Now, how did we know that's our f of x? We have this point. We have this point. We know that an x-intercept exists. We even worked it out. And we know that over here, it's a negative plus a negative, which is going to give a negative. That's how we reasoned each section of that graph. If you're thinking, how am I going to do this without a calculator? Don't worry, I've never seen this on a non-calculator exam. So if you're thinking, oh, this just looks too whacked out, like there's no kind of procedure to follow, it's all very, you have to kind of feel it out, you know. If you're worried about that, then don't worry too much. You're likely to get a CAS. Okay, I will check that on CAS, but we're having trouble loading. So we'll go to example 3. Oops, let's have a look. Okay, next one. Example 3. So now we're moving on to product functions, and I'm going to show you what to look out for here, which will help you sketch the graph. Once again, you're pretty likely to get a CAS. You're pretty likely. That's why I've said this is fairly low priority. Okay, let's grab this calculator and let's check the previous answer. So I'm going to go to the graphs page. I know it's deleted, but we remember what it looks like. Okay, so we've got, we want to sketch negative root x plus 1. There's one graph. And we want to sketch negative x. Remember, we reflected it in the x-axis. And now we want to do addition of ordinates. So we go tab. Now we want to add f1 x plus f2 of x. There we are, and that's what we got. See, because you've got the x-intercept, you've got the y-intercept there as we expected. It's not defined over here. I've got the correct starting point, and it goes negative over there. So that's what we expect, which is good. It worked out. If you want to clear all this, just tap delete heaps of times and go yes. That's how you can clear your graphs. All right, example 3. So we've got two functions. We've got f of x and g of x, and it wants the product of them. So let's define f of x as x minus 3, as they've done, and g of x is the square root of x. And we have h of x, which is their product, which is f of x times g of x. Now we need to, first part, I like how they've broken this up because this gives you some good hints about how to figure out a product function. So first thing, find the domain of h. Let's find the domain here. Well, these are unrestricted domains, so that's quite nice. However, you can't square root a negative number here. So if you can't square root a negative number, then the square root of a negative number is going to be undefined, and an undefined number times something is undefined. So our domain is going to be restricted to positive values of x or 0. So that's our domain for h of x. B, alright, we're going to sketch each graph on the same set of axes. Alright, let's sketch these. Nice. I'm going to make this super big just to show you how big your axes should be. See that? That's huge. That's how big your sketches should be. None of these puny sketches. Alright, x minus 3. I'm assuming you're all fantastic at sketching linear graphs. So x minus 3 is going to look something like this. There we are. There's f of x. Now g of x as root x. You know what that graph looks like? Like that. There's g of x. Good. Do we need to label our points? Sort of, not really. I mean, you're concerned about h of x. These are kind of like the building blocks, but just so I won't cause you any grief, I'm going to label these points. You know, just in case someone says, oh, but that, you know, that time on that video on learning intention 38, for example 3, you didn't label your points. Well, yeah, label your points. That intercept, What's it going to be? It's going to be something with a square root. I'm going to leave that. Don't need that. All right. Part C. Find f of 0 and g of 0, and hence find h of 0. Well, what's f of 0? 0 minus 3, it's minus 3. G of 0 is the square root of 0, which is 0. And h of 0, well, no point subbing it into that times that. You can just multiply these because it's the product of f of x and g of x. So 0 times negative 3 is 0. And we can put that right on our axis here because you know that they're going to ask you to sketch it. So we know that 0, 0 is going to be a point on h of x, which makes sense because the y value here is 0 and we're timesing by minus 3, so we're going to get 0. Let's keep going. Part D, we want f of 1, g of 1, and hence h of 1. Well, f of 1 is minus 2. G of 1 is the square root of 1, which is 1. And h of 1 is their product, which is minus 2. Let's keep chugging along. Part E, find f of 2, g of 2, and hence h of 2. Well, f of 2 is negative 1. G of 2 is the square root of 2. And h of 2 is going to be their product. So it's that times that, which is minus root 2. It's their product. The two numbers multiplied together. Minus 1 times root 2 is minus root 2. Now it's asked for the range of the function in exact form. Well, I mean, I'm gonna sketch it first because I think the range comes after. I think the range is an afterthought of the sketch. They kind of inform each other. But anyway, let's have a look. So they've given us some points. So we know h of 0 is 0, so we've got that there. H of 1 is a negative 2, so h of 1's about there. So h of 1 is negative 2, so that's about there. That's about right. Alright, and h of 2 is going to be negative root 2, which is negative 1.41. So it's going to be like, what do you reckon? It's going to be like somewhere around here. Now, you'll notice that this problem, you can use your CAS. So if you're wondering, well, how am I estimating these points? Don't worry too much. You could use your CAS here. I wouldn't worry too much. Alright, well, you can see what's happening there. So you can see that it's going from 0 to negative 2 to negative root 2. So you can see that it's going more negative and then less negative. So that gives you a hint about the minimum of the graph. Now, you would check it on CAS to make sure, but that's going to be your minimum y value. So let's do this sketch a bit more carefully. So you've got h of 1 is negative 2. I need to be really careful. I think it might even be on the line. Not sure where it is exactly, where that minimum is. Might even be there. But then that h of 2 is going to give you the negative root 2, which is going to be about there. Alright. Well, how am I meant to sketch this? How am I meant to sketch h of x? I've got 3 dots. Well, I know that it starts here and it's a curve, so it's going to go like that, but what happens afterwards? You know, what are we going to do? Well, we've actually got a bit more information. We know that here we have a y value of 0. And that's a dead giveaway. Our x-intercepts are really good because the y value there is 0. So 0 times whatever that is 0. So we actually have another point. Okay, well, we know that our curve is going to go like that, but what's going to happen here? Is it going to go like that? Is it going to shoot up? What's it going to do? Well, the way to figure it out is that you've got positive y values. You've got positive y values. A positive times a positive is always going to give you a positive. That makes sense. You've got positive y values here, you've got positive y values here. So everything here is going to be positive. So let's go through how we got all these points. This point we know because it's 0 times whatever gives you 0. Same for this point. These points, the question encouraged you to work them out. And we know that the curve is going to be positive over here. So let's have a go at sketching this graph. It's going to look something like that. That's our h of x. All right, how are we going to get the range? Well, the range is going to be from that point there, that -2 to infinity. Just like that. All right, so let's check this on CAS. I mean, that was pretty tricky figuring that out. This is a CAS enabled question. Let's check it on CAS. So let's do f1 to be x minus 3, x minus 3, and we'll make f2 the square root of x. And let's do their product. Are you ready for their product? Now you could write out x minus 3 times root x, or you could do f1 of x times f2 of x. There we are. Yep, that's what we've got there. So you can see it's you've got the x-intercepts, because if you have an x-intercept on either one, you're going to have an x-intercept on their product. You get all positive y values here because it's positive for the two curves. You've got the points that we subbed in, and you've got the correct starting point there. Okay, so that's good. Let's confirm using this graph what our minimum will be. So if you pop over to menu, and there's a few ways to do this. No, it doesn't want to do it. Let's try again. Menu. No, I want to analyze graph. No, here we go. You can find a minimum. So you can select, we don't want graph F2, so we can go tab. Whoops, that gives us a different one. Escape out of that. Okay, let's try again. Menu. Okay, these arrows do not want to work. But you can find the minimum. You could use a trace. Let's try tracing. No, the arrows don't want to work. Okay, very stubborn. Find the minimum using your CAS if you want to confirm that. This is really, I've written low priority on a unit schedule. The chances are it's never been on a non-calculator exam, a product function. So I wouldn't worry about it too much. Make sure you have a rough idea. Make sure you understand that the x-intercepts here, so the 0, 0 and 3, 0, make sure you understand that they are grabbed from the original graph, the original graphs, and make sure you can appreciate that a positive y value times a positive y value gives you a positive value, and that a positive times a negative is going to give you a negative. So those come from integer multiplication. So I hope that helps with sum, difference, and product functions, and if you have been, thanks for watching.